Hello everyone, welcome back to the playlist about mathematics behind AI. In the last video we've introduced the notion of differentiable functions, but we actually only did that for functions from the real numbers to the real numbers. For machine learning models, we're gonna have to construct functions that have multiple copies of the real numbers as inputs. So we actually would need to generalize the notion of differentiability to functions with multiple inputs. And let's take a look at an example here, a function which goes from R2, from the plane to R. For example, that takes an input, which is a tuple here, x and y, to x squared plus y squared plus 1. I can draw the graph and still draw it in 3 dimensions. And you see like this is like some sort of cone that enlarges, and there's always these circles that become bigger and bigger and bigger. And here I drew just a function, the graph of a function from R to R. And remember that for the derivative of this function, we were interested in how steep was the ascent or the descent. And actually this has to do with if we fix a point here and we ask ourselves what happens with the function if we go a little bit to the left, and what happens to the function if we go a little bit to the right, because we only have one direction, namely the x direction. But we can still wonder the change of f in the x direction. We can still do this, and well, its definition is we can take a look at the limits of h going to 0, f of x plus h, and I fix a certain y, minus f of x and y, divided by h. And I call this the partial derivative of f in x direction. And I know the notation becomes delta of f delta x to indicate that we're taking the partial derivative in this direction at the point x, comma, y. And so I see here that in this definition I fix the y direction. I only look at how does this function change in this x direction. And of course, we have this partial derivative. We can also take a look at the partial derivative in the y direction. And you can guess its definition. This time we're gonna leave the x direction fixed. We leave it as it is. And now we're just gonna alter a bit the y direction. Divided by h. And of course I can do this for functions with two inputs. But of course I can take a look at functions going from r to the power n to r. And then I can actually, for every I between, if I denote its inputs as an n tuple x1 until xn subscript to, let's say, just g of x1 of xn. So I can take a look at the partial derivative of this function g in each of the n directions. And this is going to be crucial when we are going to train our machine learning models. But we'll get to that. Ciao.